Hi, welcome to my virtualization tutorial. This video I'll discuss about load balancing cluster, and my agenda today will discuss about load balancing clusters and discuss about set of applications which can be run on load balancing cluster, and also we'll discuss about why do we need to go for a load balancing cluster and discuss a scenario, and also finally we finish with planning for load balancing cluster by considering various aspects. So first of all, what is load balancer cluster? Load balancer cluster is a group of servers which receives requests from the client side. In a normal scenario, what happens? We have a client, okay, that is a desktop PC or any one of your machine. When it raises a request, it goes to a single server. So the single server is managing your request. So it is running the application app. So this request, as soon as it lands here, and after that it will respond back to the machine saying that, hey, this is what you have requested. Probably it's a data or a web page, whatever it is. Fine. This is the way basically it works. Now, when more and more number of clients started assume that there is some n number of clients started requesting this app, obviously the server is unable to serve all the requests coming from various clients. That's the reason why we go for a load balancing cluster. So load balancing cluster, we have more than one server serving the request from the client side. So in a normal traditional scenario, the request straight away land to the server. Here, the request does not go to the server straight away, land on a network load balancer. So network load balancer, or generally we can say that it's a load balancer. Here I have given a network load balancer. There are different type of network load balancers available. Generally we can classify it into hardware load balancer and software load balancer. And people started using application load balancer also nowadays. Fine. Generally, when a request comes, all these requests come from client 2, client 3, client n. All these requests land into the load balancer. Now, load balancer divert this request to this set of servers according to their load. Okay. So if server 1 is having more load, and the traffic will be diverted to this one. 1 and 2 are loaded, this traffic will be diverted to server 3, and so on. This is the way it works. So we can say that the group of servers which basically runs an application or more than one application. It's purely depends on what you run on your cluster, so that we can see the definition here. We can say it's a computers collectively act as one or more logical computers for the purpose of distributing client requests. So basically the load balancer distribute the request from the client side to the server, so that each server will have a bearable load, so it will respond in a faster way or efficient way. So also this clusters provide fault tolerance of data access as well. Okay. So the implementations, so different applications we can consider. There are web servers, FTP servers, streaming media servers, VPN servers, terminal servers. These are the good candidates for load balancing cluster application. So you can put it into the load balancing cluster application. It will seamlessly work. Particularly when you take this example, streaming media servers, we do not know when the demand goes high. If there is a single server to handle all the multiple requests from the client side, obviously the system is unable to handle. So when it runs on a cluster, when the increasing number of requests comes, so many servers will be there to respond to the client side, so that it will work perfectly fine. So now let's go to the real-time scenario. Let's take this huge traffic. So this is what we see in when we travel in our vehicles. So there are multiple vehicles coming from all the four sides. Only one copy is here. He is trying to manage the situation, but it is not much effective when more and more and more number of vehicles coming on the road, and he has to ensure that vehicles are passing smoothly, and at the same time he need to take care of the violators. When the traffic becomes more congested, he would be finding it very difficult to handle the situation. Now the same condition you just apply to a server. So you have a single server, and more and more number of users are there. They started requesting the single server. What happens? The server will not be able to manage the situation. When you look at the server consists of set of resources. It has something called CPU, it has a resource of memory as well as network. When you look at here, particularly the CPU part, when you look at here, it's fully loaded. It's almost 100% of utilization is there. Again, some more 10,000 or 500 another 100 users are coming and sending a request to this server. At some point time, this may crash the server. It will go out of service, so no client can access this particular server. So what is the solution for this traffic? Now more number of cops are required, or some sophisticated mechanism is required to control this traffic. The same way, when a single server is unable to handle the situation, we need some mechanism which is we call it as a load balancing cluster. So when a single system doesn't it's unable to take the load, automatically another set of servers, it will bear the load of this machine, so that your application runs smoothly. Okay, so let us consider one scenario when clients require read and write access again and again, something like a mail server. So definitely we go for a failover clustering. So this is the typical way we normally do it. Already I discussed the failover cluster in the previous video. You can watch it that as well to understand how a failover clustering works. Basically, one server fails, another server takes care of the responsibility of this server. That's the way the failover cluster works. Fine. In a load balancing cluster, you could have some different 30 servers in the cluster, all providing access data simultaneously. This is one of the scenario. So this will improve the speed. So probably normally in a load balancing cluster, the data what we use is readable data. It's not much useful for write. So you can see here in the last point, to provide data access across multiple physical servers, load balancing cluster requires each server or node in the cluster maintain its local copy, so that it is going to be efficient. Each and every server in your cluster which is going to have storage for it, local storage. So it has a replica in it, so that it can serve faster. So probably this will work out if in case if it is a read replica. Otherwise it won't be much effective. This picture, you get a clear idea of the typical load balancing cluster. So here I have taken the example of 4-node cluster, and which is running a website called apress.com. So there is firewall which is protecting this, and so we can say that this is all these 4 servers are running in a DMZ, that is, we call it as a demilitarized zone. So we can say this is a perimeter network as well. Sometimes we can say that it's a physical or logical subnetwork which contains applications which is running, and these applications, these applications are exposed to the outside world. So that's why we call this as DMZ or DMZ, which is a demilitarized zone. So this normally these applications are exposed to the outside world, in an untrusted network, or to an untrusted network. Okay, so it is behind the firewall, so that your application is protected. So when several client requests come to the cluster at the same time, what happens? Okay, here you have multiple clients, so you have multiple users. Let's say there are some n users. So these people are passing a request for this application. What happens? The load balancer divert the request to different servers instead of passing every request to the single machine. So for instance, we take an example. There are 3 nodes exist in a cluster and there are some 9 requests comes. So how it manages the number of requests? So each node will take 3 requests. Okay, so that is the way it is basically divides it. So scaling cluster is also another type of cluster. People started using it. This kind of cluster scale it based on the load. Let's say for example, you have a server which is running an application. Now we can set a scale here. So the CPU utilization is 80%. So the utilization is 80%. When it reaches this utilization, automatically what happens? Another server come into the picture. It shares the load of this. Okay, this also will have the same application, and this knows how to run the same app which is already running here. That's the way it is being configured. So what exactly scaling is? We can say that adding another node. Okay, already I had only one node. Now it became 2. When load keep on increasing, I can say that okay, add one more. It's purely depends on the business scenario. We can add more and more nodes based on the nodes availability, as well as we can say that based on the cluster size. So that's the way the typical load balancing cluster works. Fine. So when we plan for load balancing cluster, there are certain things that we need to consider. We can say that there are some 5 key phases we need to plan. The first and very important one is selecting the application, what kind of application you are going to run in the cluster, and you need to satisfy the licensing requirements in case if you are using licensing product, something like Windows Server, and also you need to analyze the risk. And you need to estimate the server capacity as well. So how much hardware you are going to procure and how much hardware you are planning it, what is the sizing of each and every server. And also we can need think of the technology decisions. So which one is appropriate? Let's say for example, whether this server model is suited for my application or not, and so on. So the first point that is selecting an application. So for an application to be able to run on a load balancing cluster, it must satisfy or it must oblige set of things. One is called it must run on TCP/IP as its default network protocol. Otherwise, it cannot be run on a cluster, and it must utilize specific TCP or UDP port numbers for end-to-end communications. This is also again factor which is basically helping the load balancer to load balancer to manage it. And several instances of application must be able to run on multiple servers. So this is something very serious. Your application support the different instances of its running on the in a cluster. Now whether your application need to share the data, so synchronize the reads and writes to the data. Otherwise that will create a consistency problem. So load balancing cluster, it is already I have mentioned, it is only a good candidate for read access. Okay, so when there is more amount of write, this is not the better candidate for your application. Now the second point is verifying licensing. So you must verify that you have enough licenses to support the applications you plan in a cluster, because you start with one server, you got the application, you got the licensing, fine, you have to you have already have a license. So when demand goes high, you go for a cluster. Okay, you start with the traditional system. That's the way normally every organization starts. So now it becomes 2. Now do you have the required licensing for the machine? If it is not, you have to go and get one, or otherwise if you have, fine, you can put a tick, go again. So when you add the third node, do you have the licensing? Again check it. So you just plan what fashion your application will grow on a particular timeline, and you just need to plan for your licensing according to your budget needs as well. Based on your budget, you can plan it. And again, licensing will be required for each server, or together you can get it for a cluster as well. So this is again, you need to check out with your vendor for this. Something like Microsoft or VMware, you need to check out with them. And also you may need license for each virtual server instance. Now let's say you are running everything on a virtual mode or in a cloud application. If you are running, okay, cloud based or virtualization based, in that scenario also you need to check out whether your VMs, okay, you have multiple VMs running on a system. Okay, in that sense, you need to check, okay, you need licensing for each and every VM, or in a virtual scenario a single licensing is sufficient to run. So that also you need to verify with the vendor. This is again very critical, otherwise when it needs to scale, it will start creating problems. And the next point is analyzing the risk. So we need to be very careful when we configure a cluster, SPOF, single point of failure. So we need to avoid a lot of this kind of problems, like load balancing applications. You need to run only the application which required to be run on the cluster. There are sometimes your application do not need a load balancing, then obviously don't go for it. Okay, if your application really needs it, and go for it. And don't look the load balancing cluster as a replacement for backup. Some think that since you have the replicas across your machines, they think that they can use this as a backup. No, you cannot use this as a backup. And don't forget about the power protection. So power protection is very important. You have a cluster, that means a group of machines, okay, that we call it as a cluster. Ensure that you have multiple power supplies. Okay, if one of your power cut off, still it operates from the secondary source of power. Otherwise your app which is running on your cluster will go down. We have to ensure that it is continuously running. That's the reason why we are moving to a cluster, right? So we should have multiple power sources. And don't forget about disk failure. Now your server normally stores the data in a storage. Now ensure that you are not using a single disk. You should use definitely RAID. So RAID 1 or RAID 5, depends on the requirement, we have to use it. So that will ensure that your data is available, and it will withstand irrespective of your hard disk failure. Fine. So the last one, estimating the server capacity. So based on your app and its needs, you can decide what kind of server capacity is needed. So how do you check out? What are the checklists you can have? You can see that whether CPU is sufficient to run your applications. I mean the number of CPUs, and the RAM which you have is sufficient to run your application. The disk space, the bandwidth, everything is very important. So normally in a normal scenario, if your CPU loads goes greater than 60%, 60 to 65%, you can say that plus or minus 5, okay, 65, max up 70, you need another server to be at the load. Otherwise your application will not run smoother. And RAM also, you cannot use the entire RAM. Okay, you need to wisely choose the sizing of your RAM as well. And in case of a disk space, you need to see that what is the growth rate of your data. Today 10 GB, and tomorrow it is going to be 20 gigabyte, and the next week it is going to be 30 gigabyte, and so on. Now you just need to check out your growth rate, how much rate your data is growing. Accordingly you can plan for your storage, at least for an year, how much storage is needed. Accordingly you can plan and also you need to consider your budgeting as well. And solving the CPU and RAM problem, how you can solve it. Now when you have a problem with RAM and CPU, very simple, you can solve it. Okay, you have only one server bearing the load, add one more server. Okay, fine. It automatically can be balanced. And load balancing service, memory consumption. Okay, so normally this kind of applications, load balancing application, obviously consume 250 to max of 4 MB of RAM. Remaining all you can dedicate for your application. You need to calculate wisely how much your operating system takes and how much memory consumed by your load balancer, and how much RAM is required for your application, normal running of your application. And when user request comes for 50 users, how much RAM it takes, and so on. You can plan accordingly so that you can beautifully come out with a sizing. And disk cluster apps store data locally. Now you need to ensure that every of your node in the cluster, okay, need to have a local storage, and because these nodes write the data into the local disk. So you need to plan the sizing of your local disk as well. This is purely based on how much data frequently your application generate. And network is very important. And so here, network point of view, normally the failure happens in your switch or your NIC, or yeah, these are the major areas where the failure happens in a data center perspective. If a switch is failing, you should have multiple paths. You have more number of switch connecting to your cluster. Okay, so it has multiple paths. So even though one of your switch fails, it goes through the second switch. And in case of a NIC teaming, you have to combine multiple NIC cards of your server to create a team, and this act as a one. Even one of your NIC card fails, it will act from the second one. Okay, so it ensures that your application do not go down, and meanwhile you can do the necessary actions to replace it or replace a failed component. So these are the items we need to ensure that when we create a cluster, or when we estimate what the server capacity. So load balancing cluster requires these many considerations. So totally you need to remember all these things while designing a cluster. So these are the references, and for watching the video.